Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over the solutions to a fundamentals of calculus test. Let's take a look at number one. It says, write the equation of the line L1 that goes through 2, 4, and 3, 3. So to write down the equation of a line, given 2 points, you're going to be using the point-slope form of the equation of a line, which is y minus y1 equals mx minus x1. Okay? So in order to use this equation, you need 3 ingredients. You need y1, you need m, and you need x1. Okay? We have 2 points. Any of these 2 points can qualify as y1 and x1. So let's call this pair x1, y1. So this is x1, y1. And then this is x2, y2. So we can clearly see that we know what x1 is. Let's write this in black. x1 is 2, and y1 is 4. Okay, so we have 2 of the ingredients that we need. The last piece is m. We do not know what m is. In order to find m, we're going to simply use the slope formula, y2 minus y1, which is the rise, over x2 minus x1, which is the run. We already have 2 ordered pairs, x1, y1, and x2, y2. We'll simply substitute these values into our slope formula to find the slope of the line. Okay? So we have 3 minus 4, y2 minus y1 divided by 3 minus 2. Okay? 3 minus 4 is negative 1, divided by 3 minus 2 is 1. So our slope is negative 1. Alright, we have everything we need to write down the equation of our line. So if we substitute x1, y1, and m in this equation, we'll have equation of L1 is y minus y1, which is 4, equal to slope negative 1 times x minus 2, which is x1. Alright, this is the equation in point-slope form. If we desire to write this in slope-intercept form, we basically multiply negative 1 to both sides and add 4. That yields y equals negative x minus 1 times minus 2 is plus 2, plus 2 plus minus 4, so we have plus 2, and then we add 4 to that. Okay, so if we reduce that further, we'll have y equals negative x plus 6, and this is the equation in slope-intercept form. Slope-intercept form. Okay, so those are our 2 answers for question number 1. Whichever form you have, that's sufficient. All right, let's take a look at question number 2. It says, write the equation of the line that goes through 3, negative 1, and is parallel to 2x plus 3y equals 4. Okay, so again, we need a point and a slope to write the equation of the line. We already have a point here, x1, y1. So we have x1 is equal to 3, y1 is equal to negative 1. We are going to be using the point-slope form of the equation of a line to generate our equation. Okay, so we have x1 and y1, and then we need to find m. We know that the slope of this line is parallel to that line. So if you look at this line, it's in standard form. So if you have a line in standard form, there are 2 ways to find the slope. One way is by taking negative a over b. So this is a, and this is b. So your answer is going to be negative 2 over 3. That's one way. Or you can change this equation into slope intercept form. Subtract 2x from both sides, and then divide by 3. And then we can see that the slope is 4/3. I mean negative 2/3, sorry. Alright, so m is negative 2 over 3. So that's all the information we need. So the equation of the line that we want, equation. Now, one thing you want to note is that this is, let's call this L1, okay? So this is L1. The other line that's parallel to L1, so let's call that L2. So if L1 is parallel to L2, then that implies that the slope of line 1 is going to be equal to the slope of line 2. So the slope of this line is negative 2/3. Guess what? The slope of the line going through this point and parallel to that line, L2, is also going to be negative 2/3. All right. Also, if just a side point, if L1 is perpendicular to L2 or normal, if L2 is normal to L1, then M1 is going to be the negative reciprocal of M2. All right, so you want to keep these 2 points in mind. So the equation is going to be y minus y1, y minus negative 1, which makes it plus 1, equals negative 2/3 x minus 3. Okay, so that's your equation in point slope form. All right, let's take a look at question number 3. It says, given the graph of e to the x, sketch the transformed graphs. So this right here is the graph of the exponential function e to the x, and these ones right here represent transformations or translations to the original function. So we have to graph y equals e to the x plus 2. So we can express this as y equals e raised to the x plus 2. Now, what kind of translation is this? If you have plus 2 next to the x, that basically means you're going to be shifting 2 units to the left. Okay, so you see this center point right here. You're going to shift it 2 units to the left in order to generate this transformed function. Okay, so let's go ahead and take a look at what it looks like. Alright, so there goes your resulting graph. If you notice, this point right here got shifted 2 units to the right, and then you have this line right here retaining the horizontal asymptote at 0, and then following that pattern, the same as this, just shifted 2 units to the right, okay? So this is a graph of this function right here, y equals x, e to the x plus 2. All right, let's take a look at this one right here. Y equals 2 plus e to the x. 2 ways you can write this. You can write this as y equals e to the x plus 2. Or you can write this in transformational form as y minus 2 equals e to the x plus or minus 0. E to the x minus 0. In this case, you have a translation along the y-axis, a vertical translation. So since it's minus 2 here or plus 2 here, that basically means you're shifting 2 units up. All you do is shift this original function 2 units up, you'll end up here, and then just follow the same pattern. The horizontal asymptote is going to shift 2 units up from y equals 0 to y equals 2. All right, let's go ahead and sketch the graph of that function. So that's what the graph of the function looks like. You notice how this original function, the y-intercept was just shifted 2 units up to this point, and the horizontal asymptote moved 2 units up also to y equals positive 2, and there you have your translated function, y equals 2 plus e to the x. All right, let's take a look at the last one. We have y equals negative 3 minus e to the x plus 3. So for this one, we can rewrite it in transformational form as y plus 3 equals negative e to the x plus 3. So written in this form, we have two shifts and a reflection. So plus 3 here and a plus 3 here means we'll shift 3 units down and 3 units to the left. And then this minus means we're going to reflect downwards. Okay? So this center, this point right here, will be shifted 3 units to the left, 1, 2, 3, and then 3 units down, 1, 2, 3. And then this graph will be reflected downwards. Okay? So let's go ahead and take a look at what the graph looks like. Alright, so there goes the graph of the function. If you notice what happened here, this y-intercept was here originally, and then it got shifted 3 units to the right, 1, 2, 3, and then it got shifted 3 units downwards, 1, 2, 3, and then the horizontal asymptote resides right here, and it was reflected, so upon reflection it gets reflected down to this point right here. Okay, this is a line of reflection. So when you shift your horizontal asymptote 3 units to the right, it stays exactly where it's at, and then shift it 3 units down, 1, 2, 3. This is a new horizontal asymptote. It basically becomes your line of reflection. So you reflect along that line, and then this is your resulting graph of y equals -3 minus e to the x plus 3.